In this video, we will learn how to use Chebyshevs theorem. The truncated table is taken from the list of the top 2,843 100-meter sprint times ever recorded in sanctioned competition. The mean for all of these recorded times is 10.017 seconds. The standard deviation is 0.070. It is frequently very useful to be able to predict where proportions of data points will lie relative to the mean of the data set. One of the tools that is used to make these types of predictions is called Chebyshevs theorem. Chebyshevs theorem tells us that the proportion of data values that will fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1. So let's answer the question, according to Chebyshevs theorem, at least what proportion of the data values lie within 2 standard deviations of the mean? So we should evaluate the expression 1 minus 1 over k squared for k equal to 2. 1 minus 1 over 2 squared is equal to 1 minus 1/4, which is equal to 3/4. So this tells us that at least 3/4 of the data will lie within 2 standard deviations of the mean of 10.017 seconds. In order to illustrate this, let's construct an interval where anything between the left endpoint and the right endpoint will be within 2 standard deviations of the mean. So we will subtract 2 times the standard deviation from 10.017, and we will add 2 times the standard deviation to 10.017. This gives us endpoints of 9.877 seconds and 10.157 seconds. According to Chebyshevs theorem, at least 3/4 or 75% of the entire data set will be within this interval. Looking at the entire data set, we see that none of the data values are greater than 10.157 seconds. However, we also see that 150 of the 2,843 total data values are less than 9.877 seconds. This means that 2,693 out of 2,843 lie within 2 standard deviations of the mean, 10.017 seconds. This gives us an actual proportion of 0.9472 or 94.72% of the data points. Chebyshevs theorem stated that at least 75% of the data points would fall in this interval. This is certainly true for this data set. So now let's answer the question, according to Chebyshevs theorem, at least what proportion of the data values lie within 1.2 standard deviations of the mean? Recall that Chebyshevs theorem says that at least 1 minus 1 over k squared of the data points will lie within k standard deviations of the mean. So if k is 1.2, then the calculation will be 1 minus 1 divided by 1.2 squared, which is 1 minus 1 divided by 1.44, which is approximately 0.306. Calculating the interval endpoints using 1.2 for k, we find the interval to span from 9.933 to 10.101 seconds. So, according to Chebyshevs theorem, at least 30.6% of the 100-meter sprint record times will fall within the interval 9.933 to 10.101 seconds. In this video, we learned how to use Chebyshevs theorem.